Okay guys, in 9.7, the topic we're going to be looking at is angles of elevation and depression. So when we talk about an angle of elevation, alright, so that's an angle that's looking up from the line of sight. And when we say line of sight, we're talking about the horizontal line of sight. So an angle of elevation would have an angle that starts here and looks up this way. An angle of depression is looking down from the line of sight. And once again, it's horizontal line of sight. So an angle of depression would start here and then look down would be the angle of depression. All right. So based on those definitions, then what we're going to be doing is we'll be looking at a problem, okay, that involves either an angle of elevation and depression, and then using sine, cosine, and tangent to try to figure out some sort of a missing side or missing distance in the problem. Okay, so like for example, let's say we have this. The angle of elevation from the end of the shadow of a building to the sun is 32 degrees. The shadow is 40 feet long. How tall is the building? Now, the first thing that's going to help us out on these is to draw the picture. All right? So here's what we need. Okay, so we need a building. All right? Here's a building. Okay, we've got a shadow, right? The building has a shadow. And then, of course, we have the angle of elevation going up to the sun. All right? Okay? Now, one thing that you should be able to notice right away is in all of these, it's going to form, the drawing that we draw is going to form a right triangle somewhere. Okay? In this case, it's with the building and the ground. Now, let's fill out the parts that they've given to us. Okay? It says the angle of elevation from the end of the shadow of a building to the sun is 32. Now, here's the key. We've got to put the right parts in the right place. So where is my 32 degree angle? It is from the end of the shadow, right, up to the sun. So there is where my 32 degrees would go. All right, so that's the important thing to make sure that we know. We put our degree in the right place, and we also need to put our 48 in the right place. The shadow is 48 feet long. So where does my 48 go? It goes on the ground. All right? And the question is, how tall is the building? That's my x. All right, so now that I've made the drawing and filled out the right parts into the right place, now I can see that, hey, I've got a right triangle where a value is missing. I can use my trig functions. Now, which trig function should I use? Okay, so from here, it's just like we did in the last lesson. Here's my reference angle. I have the opposite. I have the adjacent. So I'm going to be using tangent. So tangent of the angle equals opposite over adjacent. When I plug in, I'll have the tangent of 32 degrees. My angle's 32. What's the opposite side? X. What's the adjacent side? 42. Or no, not 42, 48. And then so now I've got my equation. I can solve for x. How do I do it? Multiply both sides by 48. Alright. And then we'll have x equals whatever 42 times the tangent, 48 times the tangent of 32 is. That's where our calculator comes in handy. I want to make sure I'm set to degrees here and not radians. So that's the first thing you want to check. Make sure you're set to degrees. And then so now we can go 48 times, press function, that's where your tangent will be, 32. And so there's your answer. How tall is the building? It's 29.99. And our units is feet. Alright? So it's 30 feet tall. Alright, let's try another one. So the next one says a 25-foot tree cast a 15-foot shadow. What's the angle of elevation to the sun? Alright, we need another drawing. What are we going to draw? Well, we need a tree. Alright, what else do we need? Shadow. And angle of elevation going up to the sun again. Alright? So it says a 25-foot tree. So 25 is there. Here's my right angle, by the way. Cast a 15-foot shadow. So I'm putting my 25 and my 15 in the right place. What's the angle of elevation to the sun? There's your x. Okay, so the angle is what is missing this time. Again, I need to see what trig function I can use. I have the opposite side, 25. I have the adjacent side, 15. Opposite and adjacent, I'm going to use tangent again. So tangent of the angle equals opposite over adjacent, tangent. So what's my angle? It's x. What's the opposite? 25. What's the adjacent? 15. And then now we have an equation that we can solve for x. All right, so remember, x is wrapped up in the tangent function. So remember what we said, how do we get it out? We've got to do inverse tangent to both sides. All right, we got to do inverse tangent to both sides. Inverse tangent and tangent kind of cancel each other out, and it leaves me with x equals, which is what I want. And now we can go to the calculator to see what the inverse tangent of 25 over 15 equals. So again, we're still in degrees, which is good. So I'll go here, I'll go inverse tangent, and I need a fraction, 25 over 15. And so my degree measure of my angle is 59.04 degrees. All right? And so that's your idea. So remember, anytime the x is wrapped up in the trig function, you got to do the inverse trig function to both sides to get it out. Because remember what we said, sine, cosine, and tangent are kind of like square root. So square root by itself is not a number, but square root of 23 is a number. Just like tangent by itself is not a number, but tangent of 59 degrees is a number. All right, so keep that in mind. A couple more examples we want to look at. So in this problem it says the angle of depression from a kite to the person on the ground is 64 degrees. The string is 50 feet long. How high is the kite? Again, we need another drawing. So what do we need here? We need ground. We need person. Okay, we need kite. Okay. So there's my right triangle. All right, so let's put in the parts that we have here. So it says the angle of depression from a kite to the person on the ground is 64. So what that means is the angle, remember, of depression means down from horizontal line of sight. From the kite to the person on the ground is 64 degrees. So that means my 64 degrees goes right here. All right. So I had to draw this extra horizontal line because it's the angle of depression from the kite down to the person on the ground. What else we got? The string is 50 feet long. So that's 50 feet. Okay. And the question is, how high is the kite? And so the first thing that we need to notice is we don't have any of the angles inside of the triangle. All right, so I need to see if I can get one of these angles inside of the triangle. The angle on the outside of the triangle doesn't help me. Now, here's where we're going to have to think back to last semester. Remember, this horizontal line and this horizontal line of the ground are parallel. I have two parallel lines cut by a transversal. Alternate interior angles have to be congruent. So if this is 64 degrees, this is 64 degrees. All right, so these two angles have to match. And now I have an angle inside of the triangle. Okay? And so now that I've got that angle, let's see what we've got. We've got the opposite side. We've got the hypotenuse, opposite and hypotenuse. I'll use sine. So sine of the angle. And if you don't remember the equations for sine, cosine, and tangent, pull up the notes from a couple of sections ago and it'll be there again. All right, equals opposite over hypotenuse. All right, now we'll plug it in. And my angle, how much? 64. Opposite side is going to be x. Hypotenuse is 50. All right, so now we've got an equation we can solve for x. How do we do it? Both sides times 50. And I'll have x equal to 50 times the sine of 64. That's where the calculator comes back in. what do we need? 50 times the sine of 64, and we're still in degrees, so 44.94 is the right answer. That would be the height of the kite. All right, 44, almost 45 feet in the air. Okay, one more we want to take a look at here. It says if an airplane is flying at 1,500 feet, the angle of depression from the plane to the airport is 28 degrees. How far away is the plane from the airport? All right, so let's think about what we need to draw. Ground, of course. Airport. All right, there's the airport. Let's see. We've got a plane. Okay, plane. And let's see. So the plane is flying at 1,500 feet. So that means that that distance straight down is 1,500 feet. Okay. The angle of depression from the plane to the airport. So from the plane to the airport. From the plane to the airport. Okay. Is 28 degrees. So again, I'll have to draw in this horizontal line and put my 28 right here because it's the angle of depression from the horizontal side of the plane down to the airport. So you've got to make sure you're putting those in the right place. Right angle right here, by the way. And just like we had last time, this horizontal and the horizontal of the ground are parallel. So these are alternate interior angles. So this would be 28 degrees. The question is, how far away is the plane from the airport? That would be this distance. How far away is the plane from the airport? All right. And so in order to set that up, we have the opposite. We have the hypotenuse. We're using sine again. And so the opposite, so it would be sine of theta equals to opposite over hypotenuse. It's always good practice to write the equation down first, so it helps you keep everything straight when you plug in. What's my angle? 28. What's the opposite side? 1,500. What's the hypotenuse? X. And that's the equation that I need to solve. How do I do it? Times x to both sides. So that'll leave me with x times the sine of 28 equals to 1,500 because the x is canceled there. I need x by itself, so I'll want to divide both sides by the sine of 28, sine of 28. That'll cancel and leave me x equals whatever 1,500 divided by the sine of 28 is. Let's see what it is. So we'll go fraction 1,500 divided by the sine of 28. And so there's your answer. 3,195.08 feet away from the airport. All right. So there you go. All right. So again, draw the picture. As a matter of fact, I think I was nice to you on the quiz. I gave you the picture on the quiz. So you won't have to draw the picture. You'll just have to use it to set up and solve the correct equation, all right, for the missing part. All right. So there you go.